So welcome to everyone. Today I have to prepare for a talk later this evening, and I decided that I'm going to create like the typical camel example, which is a calculator. But to make it actually interesting, and because many of the people aren't going to have OCaml installed, we're going to just use the Dream Playground. By use, I mean abuse. We're going to abuse the Dream Playground to create, kind of just let people get an OCaml environment in their browser right away, a native OCaml environment with some OPAM packages installed. Now that we're going to use them. So I'm going to probably try to write the parser during the stream. I don't know if we'll, like, I mean, the actual calculator itself is going to be pretty easy after that. It's just the parser. I want to like write the parser during the talk, so, even though it's probably going to be trivial. All right, let's see. Let me make sure. Yeah. What do you mean by my PL? Like my programming language? The programming language here is OCaml, but maybe in a way Dream is my PL. Let me just, hold on. I think, let me get the overlay set up too. I accidentally exited it earlier. Just hide these. Okay, good. Right. So I'm gonna go. I'm probably just gonna do this using it like one of the examples and do it there, and then later I'll just paste it into the playground. Hey Anzi, welcome back. Good to have you again. Okay, so yeah, I'm on master. Let's just do it here. I think the talk isn't going to be recorded. I did ask about that, but I don't think it's going to be recorded. We'll probably do it next time. So like this is my first time trying the Dream Playground, abusing it as an environment to do talks in. Yeah. All right, I'll show you in a second. So this is what the language here is OCaml, and Dream is a web framework that I like basically built in for OCaml or in for OCaml. If I can just get please a browser tab. Sorry, I have the browser in a different monitor. So OCaml.org is the language. It's this like functional programming language, and by functional we mean like really approximately functional at this point. And Dream is this web framework over here, which kind of tries to play well with OCaml, like what it is syntactically. It tries to really like bring out the best in OCaml's like syntax. The best, I mean, of course, in my opinion. I'm very biased, of course, as the author. So it has some docs over here. If you'd like to, like all of Dream is here in one web page. Okay, yeah, good, good. Yeah, Dream is on one web page here. And actually, even here, there are links to the playground. So it has a bunch of examples, and all the examples are loaded into the playground. Or it can be like, good morning, Arad. Right, if we run this, this generates a whole new server. Or maybe it doesn't. Yeah, it does. Okay, here we go. And this is like a fake browser that's over here on this side. So this is Dream's playground. We basically have Dream and a bunch of other libraries loaded into like a Docker environment. And this thing just like builds images on the fly. So it can create like a little, excuse me. Let's see if I can even program in Dream. Yeah, take a look. I mean, I'm gonna be programming for the playground anyway right now, so I might as well just like get used to this again because I don't think all I've done with the playground in the last year is occasionally notice that it's like not working anymore and restart the server. So Dream get, let's say the root. And let's say, what else is here? Anzi. No, let me actually try to spell your name with all the H's. Just referring to or a good time of day, right? I guess it's like day for you, assuming you are where I think you are. And dream.get, Zeklar. Yeah, 1 second, I'll answer that in a second. Okay, so if we do this, I really hope it just runs. Nope. Because why? Because we need do we? Yeah, I guess we do. Because this is the stupid syntax. Sorry about that. I don't think we even yeah, we just need this right here. We just pass all this straight to the we wrap the router basically in dream.run, and we don't need all this indentation here. Just being a pedantic about indentation. 1 second. No. Yeah, because we need to do like dream HTML or dream.respond and dream HTML. Okay, good. We're running. So this is a fake browser here, and if we type like if we just go to the home page, we get this greeting, and if we go to /onz, we get this greeting, and so on. Yeah, so the framework is like trying to like expose the like basically provide a coupling between the syntax of OCaml and like how you and like the syntax of the web framework, and just make it as syntactic and clear as possible, at least on the top level. Obviously, as you write a really complex web app, you're gonna have complications, but that's just a result of the web app developing. Anzi, how far is quick HTTP3? Yeah. I remember actually asking about that as well recently, but I don't think let's take a look. Oh man, again. Browser. Well, yeah, it looks like there is development, right? We'd have to ask Antonio about that. I did ask him recently. I don't think it's ready for usage, but I don't think HTTP3 is really used that much at this point either, like out in the wild anyway. So I think basically Antonio caught OCaml up with the state of the art in HTTP anyway. So we're kind of just like maybe only slightly behind. Modulo bugs, of course, right? We don't have really bugs or optimizations in OCaml, but in terms of just like having the actual protocols implemented, like more or less correctly, we have that. We just need a lot more usage to like find all the warts. All right, yeah, so anyway, this is the playground. So what I'm going to do is, since basically if you have a browser, this over here, we can take this address, and this is like the actual running web server. So we can simply, you can actually go, like, you can abuse this web server. Let's put the logger in here. So for example, if you want it to be really annoying as a viewer, what you could do is, so now you see we have log messages. And when I submit a request here or even here, just in the tab that's out in the wild, we get, we should be getting, actually, what's going on here? Oh yeah, this is a different port now, because it's generating a new server and just allocating a port for it every time. So see, that's our request from the other tab. So basically, as I give the talk, any of the like attendees will be able to just visit whatever we're building and submit requests to it. Although the port will keep changing, so it's going to be a little bit annoying. But yeah, that's how it is. Because actually, in true functional style, these sandboxes they get a permalink and they're immutable. Although I do periodically delete ones that aren't used for a long time. So I could, like, for example, you could take this permalink and just open it in a different tab and just make your own edit, like, I don't know, a bunch of exclamation marks, I don't know. And after I run it, which causes it to compile, obviously, you get a new permalink. So that like essentially forks the playground every time. So attendees can just sit here and just create like their own dream servers whenever they feel like not really paying attention to the talk anymore, right? They get inspired or something, or just want to like try to hack it. They can just create their own web server. So I'm going to basically use this for talk for the first time. I don't think this has ever been done. So I'm going to see how it goes, and we'll record it afterwards, maybe after this first time. Okay. Yeah, and that, what I was saying about being annoying is with the logger here, we can like, for example, put like a message to me or something into the like user agent, for example, and the logger will log it, and you can just like put in like whatever you want here, including like bad things. But like you shouldn't do that. Like make the person giving the talk like turn the monitor up. right? So probably that's a good reason not to use the logger, given that people like to troll. Excuse me. Yeah, I was like sick last week, so I still have a little bit. Sorry about that. Okay, so my goal today is to build a calculator inside this thing. I'm gonna just build it really just outside, and then just paste it into the playground. So the way it's gonna look is I'm gonna start, excuse me, I'm gonna start a tmux session and just create, okay, 2 panes. And I think in one pane, actually, I'm not gonna even probably use tmux, so we can just do this here. I'll just close everything, so I'm starting over from scratch. Yeah, so we can set this up the way we want. I'll probably have a terminal on the left. And on the right, I'll take one of the examples and just convert it into the calculator inside this repo in a branch and paste it out later. And the obvious one is just to do hello ML. And we're basically going to, here I'm going to run dune exec hello.exe watch. Actually, I don't know if that's even a good idea. Yeah, it's a good idea, but I want to kind of run it in the background. So actually tmux might be good for that. Let's run a tmux session in here and do the watch here. That's a bad idea. Yeah, it's like a whole different environment in there. All right, let's just do it this way. Okay, why are we even looking for p time? It's weird because the previous build worked fine. Yeah, I guess just the environment variables got messed up with the OCaml switch. Okay, so I'm just gonna verify that, yeah, it's rebuilding. And let's, I guess the easy way to do, since I basically just need a parser, is I'm going to first write the parser outside anyway. So I'm gonna just feed it strings from inside this file, and that way we don't have to submit requests. And we can just get the output inside this over here on this pane automatically every time. And then at the very end, I'll just wrap it in a post request so we can send strings to the calculator. And then after that, I'll figure out the HTTP IE command to access it. So let test string, or actually let parse s be, so how do we parse this? Basically I'm going to just write like a hand rolled parser for calculator. The strings are going to be like, I'll write myself a comment here so I know what we're looking at. Like number's going to be in general 2 digit, 1 or more digits. White space will be insignificant. So we'll have like basically a couple operations and we'll have parentheses. Like 15 or something, 15. And the calculator will just, and all these will be floating point numbers. But we're just gonna parse them. Like we're not gonna do like OCaml syntax a floating point or anything like that. All numbers will just always be a floating point. Basically JavaScript numbers. Okay, so we need something like, I'm kind of hoping to be able to just get this done in one go. So we need something like parse number, position, so index s, match s if index is more or equal to, and this parser isn't going to be like super format or anything. So for the number, we need an accumulator. And we only call this function only called when as that index is a digit, and we don't need this guard actually, because we're only going to enter this function when we know we're already looking at a digit. So the initial accumulator will be 0, and when we see a digit, then we basically match. We don't even need that. Let number be. as that index pipe through character. What's going on here? I guess we don't have a Dune or the language server helping us out. Let me just switch to a switch where I know I have all that installed. No, okay. I'll fix that in a second. Let me just make sure we even get. All right, no, I'm gonna fix that now. So okay, let's see. Do we get annotations? And let me just exit this completely and make sure I'm just starting in a good environment. So we're at code dream. Let's switch to 5.0 because I'm pretty sure I have OCaml LSP installed. And then clear, and then start VS Code now. Okay, at least it knows that that's a string. That's good. Yeah, I don't know what's happening with this. Let's do one build. So sometimes you need to ask it to do one build. Yeah, okay. Yeah, and then we need to just go to the example, also probably build the example like once, just do an exec. Okay, good, but we need to, yeah, okay, so at least we now know this is an int. Okay, good, and this is int char, so we need like char dot nice code. Okay, so when, and then we need to, this is going to be a recursive function. So let digit, so we have the char code and we need to subtract OX30, I believe, because we're going to just assume this is all ASCII. What's going on here? Is it like, it's probably not this, by the way. Ignore digit. Okay, just operator precedence issues, a little bit annoying. And let's just actually test this first. I'm just I like to test everything like right away. This will be our little testing thing, and we can actually just comment this out. So we don't get syntax errors from the let being there. Like just spurious syntax errors while we write a bunch of code up here. Parse number 0. Yeah, okay, and this is also annoying. It's gonna be annoying that we're gonna have warnings while we build this out. So let's do profile release. If I can spell. Parse number 001. Where's the actual exec? That's weird. Okay, it's doing it this way, but it's not doing it if I do watch. Oh yeah, because of the output. Okay, I guess no watch for now. That's probably like a bug that there's a bug that's going to be fixed with the like this bug is going to be fixed in Dune 3.8.0 once it's released. It's going to be available. And anyway, we're just not going to use Dune exec. Unfortunately, we're going to have to do it this way, I think. or man, that's really annoying. Yeah, because this way we can see everything clearly. Let's just print a new line from here synthetically for now. And is this really just not going to work if we do that test watch? It's really janky, right? But this kind of thing should be easy to fix, so hopefully just fix it soon. Okay, yeah, see, we just need like a bunch of new lines because like this is clobbering. Yeah, all right. All right, we found the bug in Dune. Let me just Dune eats final line of output after Dune exec watch. Just give myself a note to report this stream later. Yeah, that's just the state of OCaml tools, but it's getting much better. Until 3.7.0, we didn't even have Dune exec watch. Okay, now we can develop reasonably, I think. So yeah, if we get like 9, we'll get 9. If we have 0, we'll get 0. Okay, good. Now, we need to do something like this. The next accumulator is going to be the current accumulator times 10 plus digit. And we need to, I just wrote that expression out, and I'm going to use it as a subject expression somewhere else. So match, I'm just going to do let index equals index plus 1 and match if index is more than or equal to string that length s, then act. I think we need to return the index as well. Yep. Else, yeah, it'd be so nice if index was just a ref, but I'm trying to like show OCaml during this talk, not like show C, so I'm gonna just not do that. Otherwise, we do match s index with. You know, actually, we could be smart. I'll do it. I'll convert this to the smart way when we're testing it. So if it's 0 or 1 or blah blah blah, it's gonna be actually. Isn't there like a pattern like this or something? Parse number. Act. Okay, so I think it's clear actually just rebind act to whatever I wrote over here. So we basically push a new digit into the accumulator, and then we parse number act the new index and s. Otherwise, we just return again. I believe that should work, except I don't know how to do this pattern over here. Does it work? Even work? Okay, let's look this up because there's like a sneaky OCaml pattern that actually, like, I wouldn't actually want to use this necessarily because it's not. Yeah, okay. Is that clear? Let's try that. Nice. And here we just need to do the accumulator is the first thing we return, so we just do this. Nice. So this is if we parse 0, 1, if we parse 0, 1, 2, we get 12. Thank you, Lesby and Zeklar. Yeah, so now we have it. I believe this function is like correct-ish. The one thing we can do is we can make this exception, I believe, in valid argument, right? Also ACK index, and the second we're going to combine this into one big pattern. So if we do it, let's do this 1200 ABC. It should just give us 1200 because it's only parsing the prefix, which is how this function is supposed to work. And then now that we have this exception pattern here, we can just do this. And then OCaml since whatever version supports this kind of pattern. And if we just let number index be parse number. Let's just print to verify that we're stopping at the right place. We'll parse, print the number in the index. Okay, index 5. So that's 0, 1, 2, 3, 4, 5. Good. So the index is correct-ish. I mean, hopefully this function is so stupidly simple. Let's just test some edge cases. Or we can actually, I can do the talk, I can just be like, I wrote this function like in a hurry. If you see some like dumb edge cases, go ahead and just, yeah, we expect this to happen because there's a precondition on calling this function, that this is only called when we already know there's a digit there. So if we parse A, it should actually kind of just fail. But if we pass in like 1A, then we get this, which is correct. Okay, I claim that this is correct by, I don't know what, like incompetent authority. Okay, so now we can parse numbers. Let's parse expression. I don't think we really have anything else to parse because all of our like any other things that require a recursive function to parse, because everything else is going to be a one-character symbol, and I think we just like eat it recursively. So parse expression I don't know what accumulator we're gonna need, so I'm gonna just do it this way. So this is basically just parsing. This is basically the top level entry point. It's almost certainly going to be recursive. I can press the correct keys. Match S index with, and I'm immediately going to do this exception, invalid argument. I don't even know what to do. Let's actually, we need like a type at this point because here we're returning digits, integers. And here we need the type that we're going to return. Type expression is going to be either a number of int, a float. So we return only here, right? So let's do float of int hack, and this is gonna break our printer, but that's okay. We'll fix that in a second. Number of float, or let's do plus for now. We'll just add the binary operations later. So plus of expression, cross expression, and I don't know how to express parens. I don't think we even need to express them in the AST. Right, so let's just stick with this for now. So if we won't have negative numbers or negation. I'll just leave that as an exercise to the attendees. So if we have an empty string, the issue here is like, I think we're gonna have to handle the empty string separately. So we're going to assume that it's a non-empty expression, because the issue is the whole input might be the empty string, or we might have a recursive call to starting at a paren to parse an expression, but it just ends, and that's why the inner string that we're parsing is empty. But this is actually a syntax error. So we kind of want to maybe distinguish these, or maybe they are both syntax errors. Anyway, we'll just assume that this is a there's at least one symbol, or should we? Yeah, let's just assume that, and then we'll figure out the edge case later. So I'm gonna just comment this out. So if we have 0, 9, then we don't we staying at the same index, we just parse a number. So the initial accumulator will be 0. The index is the same, and the same string. It's always going to be the same string. Parse number, and then we just feed that to the number constructor. Then, yeah, actually, yeah, this parse is not going to work. Like, yeah, we need like semi-tokenization. That's really annoying. I don't want to do that. I want to make this as simple as possible and as trivial as possible. So like after number, we have to parse like something else. So we need like okay, let's just write this function. It might not be the top level function afterwards, but I know like what this function is doing. If we have a paren, then we need to let expression equals parse expression at index plus 1 s in. Now, if we have a paren after we parse a complete expression, we expect another paren. So match. We're gonna get into trouble with OCaml nesting. Less expression. Okay, so this is gonna have to return an index. If we have a closing paren, then we just return the expression. So we need a function like this. And at this point, I need to just like write out the grammar and just I usually like write out a toy grammar and then just follow the grammar to write this recursive descent parser. That's really annoying. I really don't want to do it. What I don't want to do right now is like you can, because you can encode like associativity and precedence by writing the correct recursive descent grammar, but I really don't want to do associativity at this point. I want to just have number or number plus number, and then I'll leave that maybe as an exercise for the reader to write a grammar. Because the thing is, this whole like calculator has to just be clear, like for people who are seeing OCaml for the first time, right? I don't want to like basically write a grammar that has like rules that are structured in such a way that they accidentally happen to encode as left associativity and precedence, because they have like multiplication expressions, multiplicative expressions, and then additive expressions. Yeah, no, it doesn't suck that much. It's like the grammar will look like this for for precedence. It'll be like let expression, or expression is either a number, or like what's the top level expression? It's going to be an additive expression. And an additive expression is, see that thing, if I reach 100, it's going to start exploding. An additive expression is like I don't actually remember. I would need to work this out. I've literally haven't programmed much in like 1 year, but I've written these like multiple times, and it's going to be an additive expression is either a multiplicative expression or I think it's going to be something like, yeah, I really don't remember this. Like there's going to be, you encode the like you drop to a different, anyway, basically you separate these things inside the, you separate the precedence level inside these production rules. I just need to play around with it again. And this way and then like at the end you go back to expression or something like this. And that way you kind of just, out of these production rules, you accidentally get all the precedences and associativities. But I don't want to do that right now, since I don't even remember myself. Off the top of my head, like I need to play around with it. Yeah, it's something like this. So, like, first of all, I don't remember it. Second, if I walk into this into a talk with this, then it's gonna just be a disaster. So we're literally going to just have plus expressions, and we have to, all of them have to be inside parentheses. So it's gonna be like really bad as a calculator. But we'll just leave it for exercise, or maybe we'll just do it online during the talk if someone like really presses for it. If I get like 5 attendees that know what they're doing with parsing, then maybe they can just tell me what to do, or they can even do it themselves since they have the playground to access. Okay. So we basically, like the way these expressions will look like is there'll be numbers that will either end. So we can actually do this at this here. They'll either end or they'll have a number or so let first. See, I should never program with before I always programmed without OCaml LSP, so I never get all these things which are now really annoying me. These like warnings, like which are just naturally the result of the code being edited. It's like just annoying me really seriously right now. Okay, so match as we have a plus Yeah. Yeah, it'd be nice if there's some kind of backup interval where, like maybe if you just typed, I don't know, or maybe if it's like if it realizes that it's highlighting like this many lines and typing was done within like the last like whatever amount of time, then just don't highlight it. Um, so let's see. In this case, we've parsed a number, a plus symbol, and here we're gonna have a bug if I don't do index plus one. It's fine, by the way. We're gonna find these bugs in a second. I'm like super rusty in just programming in general and OCaml. Then we return evaluate to. I mean, we're trying to speak FP here. Number first plus first and second. Otherwise, if we get anything else, we're going to just even if there's a suffix to the string. Really? So if I just write assert false, okay, that does help a little bit. But it's like freaking out about my I guess it's probably freaking out about the matches being incomplete. And if we get anything else, then we're not going to try to like deal with the suffix. In general, we shouldn't. So we just return number first. Actually, this is not correct anyway, right? Because it has to be number first. That's not right. We just return first. Okay. I hope. And if we get a paren, which is down here actually, so no need to type it again. This is like my actual programming experience is never this messy. It never looks like this in the past at least, because I'm like that guy that just uses Notepad and doesn't use LSP. But I was like trying to get the setup for the stream, and now I'm like, I don't know. I mean, I do appreciate the hints and everything, especially since during the stream, like the attention of the streamer is like much less. Like I have much less attention to the actual code because I'm also on stream. So it definitely helps me in that way, but it's also like distracting me with this freaking warning. Let me just put like a little, I mean, something like this, right? No. Okay, I'm not gonna try to guess. I'm gonna just deal with it, whatever. Okay, let's fix this this error here. This expression should not be a constructor. We expect the type is alpha cross beta. Yeah. Okay, let's bind the floating point numbers. Bind these at the end. Call the constructors at the end. Not call the constructors. Apply the constructors in the end. On 939, we have, and I'm falling back into old habits and being unclear about these tuples here, these pairs. Let's be clear. Okay, expression index parse. What's the issue here? Okay, yeah, because we need to, in all cases, return the index. It's getting a little more verbose than I wish it was, but on line 41, yeah, if we had like some kind of token stream, especially if it was a list, then we can just eat the like the stuff that's inside the cons cell. But because we have a string and it has like this random access, we have to carry this index around. A little bit unfortunate, not very, not as like functional and clear as it could be. Okay, good. So we expect like errors here. So if we have close paren, then we return the expression and index plus one because we eat the close paren. Okay, good-ish. At least we have a different error at this point. We also have a problem. We're gonna have a problem here with. This is one of these unfortunate things about OCaml. And just for consistency, so that this is like refactoring friendly, because if someone were to move this case to the top, if it didn't have this begin and end, it would mess up with precedence. Yeah, I don't. I mean, I could probably do it, but that's going to be more confusing for people, I think, for like OCaml beginners, right? Like, what is a sec? A seek, right? Like, it's probably good for us Okay. Yeah. What time is it anyway? Yeah, it's like taking a good time. It's good that I'm doing this ahead of time and not during like the talk. I just need this parser to be like in scope. We can write the web app later very easily, I hope. Nice. LSP started freaking out, stopped freaking out about my entire program. Like your entire program is wrong and it should just be thrown away. That's like basically what it was telling me this whole time. But now it's just this part. Okay, let's see. Begin match S index with what's going on here? Partial match, that's expected. The event is just like a friend invited me to give a talk at a university. It's like the talk is gonna be probably gonna be like for like 2 people. Maybe like nobody will even show up. uh, but yeah, we're just introducing some people to OCaml. It's just a little like OCaml demo. But the people are gonna be like, what does it be like even like why is it even worthwhile? So I just want to show them an example of an AST, even though this is like so it's so primitive that like I don't even know this if this qualifies as like showing off OCaml. But at least I can like sit there and just expand this type into something much more complicated. I want to disable an extension. I'll do that later. Okay. What's the issue here even? On line 41, 43, yeah, incomplete match. So if we get anything else, after a run, after we parsed an expression, an internal expression, it has to be closed by a paren. So at this point, we just like, let's just fail with, even though it's gonna go into Dreams log and create like a nasty exception, we're going to just fail with like syntax error or just expected closing parenthesis. Okay, ish. Okay, ish. What else can an expression start with? Actually, nothing, right? In this syntax, the beginning of an expression in this grammar has to be either a number or a parenthesis. The only way you ever get a plus is after a number. And actually, this is not correct, right? Because the second, this thing after the plus could itself be an expression. So after, we don't expect to parse a number, we expect to parse an expression. So this is going to give us like, it's going to give us like right associativity for plus, which is a little bit messed up, right? But that's okay. Since we don't have any other like we don't really have anything here. This whole parse is just wrong because yeah, I'm like afraid to even explore all the cases. Let's see. Yeah, because in general, after any expression, so if we have a parenthesis after this paren, we can also have, so let's just, okay, we need like virtual recursion and everything, I think. And because, all right, the way I'm going to write this in order to reduce the amount of thinking I'm doing on stream. Like eventually I'll learn how to think on stream, but not yet. Because if we have a closed paren, then we have, again, let first index be this. I could have just bound these separately, but I'm just like, because we again need to match after the first paren, we can also have a plus. That's why I was writing that second function, because we basically need to factor this out into a function. Right, every time we see plus. So the right way to do this is just to parse an expression Okay, I don't really need to factor this out into function. I'm gonna undo everything I just tried to do. And we need to let expression equals, first we try to parse an expression, whatever it is, whether it's a number or begins with the left paren. And then after we do that, oops. After we do that, yeah, there's no way they're gonna understand this parser. I like if I was going to publish this parser, for example, I would like rewrite this so that, for example, this would be passing the expression index to a function, so that it's clear where, because I don't like it when the bindings are like remote from where they're going to be used. So something like this, right? This or some other way of reordering this so that the bindings are near where they will, like they basically follow the expression that generates them, that gives the values that will be bound. But I'm not going to do that right now because, again, I'm rusty and I kind of just need to get this done because we're not going to like go deep into the parser. Parser is always just a little bit nasty anyway, especially handwritten parsers, of course. So an expression can't start with anything else in this. So fail with, in this case, just expected number or left parenthesis or opening parenthesis. In At this point, we try to search for a plus. And if we have a plus, then we try to parse the second expression, and then we return plus of the first expression. So now the first is out here. The first expression is out here, and it's just number. And we can also, at this point, we can probably just wrap this in a number to simplify the syntax. I'll do that later after we get this correct, because that's basically just like variation. Yeah. I probably should, but I need to like learn menhir first. If that's how you even pronounce it. I don't know how to pronounce menhir. Menhir? I don't know. Anyway, plus, and yeah, I should consider menhir for this, but then people who have never seen OCaml will be like learning two syntaxes, and I didn't want to subject them to that either. It's a pretty constrained environment. Okay, so if we see a plus, then we try to eat this another expression, and we just do this. Otherwise, if we don't see a plus, then we just return the first expression in the index that we already have. And I think that's it. And we have a syntax here because we don't need this chunk anymore. Okay, so now let's also do a printing function. It's just, we're not gonna have anything else to print here, so we can even show off OCaml in this way. And we really should move the printer next to the type definition. So number n. And if we have, excuse me. Yeah. Yeah, exactly. I considered writing the AC directive, but I also want to run this inside the Dream Playground. And I want this to be accessible. Like I don't want people, like I want them to be able to work with this without installing OCaml. I guess they could write the AST in the playground, of course, but I want them to be able to just send like post requests using HTTP IE or Perl or whatever. Yeah, I want to show off both OCaml's like syntax and capabilities as a language, but also show off like some of OCaml's libraries. Of course, I'm like very biased, and I'm going to show off Dream, but If we have plus, I'm gonna just print it in parens always. So I'm gonna be like a bastard about this and just use the n prime syntax that everyone hates. In this case, we do printf, except not because, yeah. This isn't even print anymore. This is toString. I guess we could call it show. Let's call it show. Well, what's happening with LGPL? Are you talking about like the base OCaml itself? I forgot like what because I remember there's some LGPL libraries. Even I was like working on some that I would transition to MIT. Show n. Let's put a nice space here. This show n prime. Yeah, this is like I'm not gonna do this because people are gonna freak out when they see this. Let's do sprintf. So we just do s plus that's actually gonna be f plus f. No, it's gonna be s actually. It's gonna be s because we just compose. This is like really inefficient, right? Because we're allocating like all these strings, but we're trying to be like equational reasoning, right? Not efficient. Mm. Yeah, I actually don't know what the licensing interactions are like here. Okay, so let's do parse expression. Let me just if parse expression turned out to work, I'm going to rename it to parse in a second. So let's do parse 1 plus 1. Oh yeah, okay, we're just not going to support whitespace here because that's going to just give us more cases. Yeah, that sucks. You mean abstractions, licensing abstractions? Show print and line. Yeah, okay, there's no parse function. Okay, because the initial index is, yeah, so maybe the parse expression will just be the helper. Yeah, it's going to definitely be the helper because we need to like index out of bounds. Great. Because yeah, eventually the parsing will stop somewhere, right? So yeah, because let's say we will consume the whole number. What's the next thing after the number? And this is the case where we need to add this over here. I'm not gonna like, even though there's only a few matches here. Nice. Okay, but I don't want this little point here. This is really stupid. I don't want string float here. Let's do printf. Printf. Is this gonna work? Nicer in terms of the format. No. I think it's like 0.1d. Let's print it to only one. Let's print like two significant. These aren't really even significant digits. It's just 2 digits of decimal precision. I don't remember like all the format strings in detail, whatever. Let's actually write the evaluator. I'm gonna write the evaluator with them, but I have a couple of minutes. So let's actually, before we write the evaluator, let's write the, yeah, ANSI. Actually, isn't, I think LGPL works slightly differently, right? Aren't you still allowed to link? I don't remember. Oh yeah, okay, yeah. Yeah, because you're building like from monorepos basically when you are like building from the universe, right? In Mirage. So parse expression is going to be parse expression 0 first, right? What's going on here? Just parse this. Yeah. Yeah, exactly. Yeah. Yeah, because of yeah, it's because of Duniverse. Is that correct? Like with Mirage, like 4. I've only started using Mirage recently, like as part of Dream development. Basically, I had to like do it. Like I've always wanted to use it, do it, but I never had time to. But I decided to finally like actually as a maintainer support Mirage. So I finally installed Mirage 4, and it creates like a big mono repo. I think for your project to like quote unquote link to, even though it's not real linking, as I understand. Okay, so basically this works. So then from now, we're going to just write and delete this. Dream router. Yeah, we'll put the logger in, I think, in the beginning. I don't think anyone's going to, I mean, it's going to be like 3 people, and it's not going to be like video taped. So I don't think it's going to be a big problem with people like trolling the stream or something. There's no like no stream to troll. So dream dot post. Well, no, before I do that, let's write the actual evaluator real quick. This is like going to be stupidly simple. Let's put some white space here. So this is all parsing. This is the actual type definition. This is just garbage for, I'm going to delete that later. Garbage for dealing with Dune's lack of new lines. Let evaluate. I guess what let's do for the evaluator for expressions first. So for number, n, just the number. Wait, are you saying, I think LGPL allows static linking, right? It doesn't, or does LGPL only allow dynamic linking without becoming infective? And if we have plus of 2 expressions, so E prime. Wait, hold on, what did I do here? It's not N and N prime, it's E and E prime. Just trying to use subjective variable names. And then we do evaluate and also E plus evaluate E prime. And then I'm gonna just like shadow this. It's not a good idea, but it's, so we're gonna have something like, actually, you know what, let's not shadow this. Let's create like a little functional pipeline for them to see. So evaluate, like, sorry, parse. So we can even do it like this. 1 plus 1, like feed it to parse, and then feed it. It's like really show. It's gonna look nice maybe even inside the dream handler. Yeah, because now we need to do yeah, nice. So let's evaluate some expressions. Like in our amazing languages. We never really tested parentheses, right? It's gonna be embarrassing if this just doesn't work. How about 11 plus? Let's use some symbols other than 1. Okay, that looks kind of right. This should be like 16, right? And that's 17. I see. I see, Anzi. That seems unfortunate. Yeah, that's one of the reasons, like LGP, a lot of people objected to LGPL, so I switched like LWT from LGPL back in the day when I was maintaining it. And then bisect, bisect doesn't get linked into your binary, but sometimes it does because people just don't feel like cutting it out completely. And the bisect was GPL, so we definitely switched bisect away from GPL. Okay, so it kind of like sort of works. it's actually probably good if we find bugs or if we make extensions during the talk. So it's not a big deal that like this is like some of the jankiest code I've ever written, probably. Okay, so now we just need to wrap this inside a post request. So we just do like dream that. Oh yeah, we do need the request. Excuse me. Dream.body request gives us a promise. So that's gonna be nice. This is one of the things that's gonna be much nicer with EIO. Getting the body out, because you can just build one big functional pipeline, but it won't be functional, right? Because it's gonna do like imperative effects along the way. It's gonna be like all blocking like fibers. Yeah, yeah. I think LGPL is used on OCaml only because of tradition, basically, as far as I know, right? Because it's basically like Linux, like just following this tradition. Let LWT body. Let's just do this. Let's pass this to string.trim. Pass that to parse, then evaluate. So there's going to be a couple people, I think, in attendees, if they show up, of course, that are like into compilers and interpreters. So they're going to just be happy to see this like whole chain of like parse and evaluate. And the build system in this example is kind of broken for what I'm doing with it. So I'm going to just, there's a different example that already has this. They used to, but then they switched away. Nice. So we have the server like supposedly, allegedly running here, but there's nothing at the root. We can with them we can actually just add a home page. So we'll just do it as an example. So now that we have this server, I'm gonna just send it into the background. Oh man, and the watcher is also here. A little bit annoying. Let's just create a terminal here then. If I understand it correctly, we can just do this and pass it to HTTP localhost 8080. And if anyone knows how to do a post request off the top of their head, nice. Okay, so I just guessed. What is CSIL? It sounds like one of these. Look at that. So our amazing web server is working. This is like an API over here. The most janky API I've ever seen. But we can do extensions during the talk. All right. So I think that's, I mean, okay, for a final test, let's just paste all this into the playground. Okay, I'm gonna not paste these. I'm gonna paste everything actually and then just delete things, the parts I don't need. Yep. Yeah, we're not gonna be able to send post requests to it from inside this little interface. I probably should actually, that's a good thing that I noticed that during the stream, because that's actually playground how to send post requests through the web interface. Okay, so we have like all this code, the parser, the evaluator. It sounds really fancy, the evaluator, but it's like extremely stupid. Yeah, it's really annoying when you have a license, of course, as everyone knows. It's like the same as something else, but just has different wording, because then you have to get like 5 lawyers. If you're like a big company, if you're just like just someone, then you don't. What's happening? Yeah, because there's no page at the root, and Dream doesn't just if you access this. But actually, that's weird. That is weird. That it's behaving this way. But let's just see if it's up. So it's now not at localhost anymore, but it's at HTTP DreamAS 9081. Okay. For some reason, let's just see if we still get. Let's put this route at the end so that we can scroll past. I'm gonna put a dream.get. And this white space has to go. Let's see if this works. Yeah. Yeah, I agree with that. Okay. I don't know what's going on with the playground. I'm gonna just do the dumb thing and just reboot it. Maybe it's 6, my favorite command ever. Let's see if that wakes it up. Yeah, because I'm gonna be really disappointed if for some reason that just doesn't like if there's some weird reason why this doesn't build, but I don't see why, like, because all this is just pure OCaml code, right? And given the compiler works inside the playground, it should just work. There's a European public license. All right, that's annoying. Yeah, that's annoying. Let's see. Probably not even up yet. Okay, it's definitely up now. That is really weird. Oh yeah, I know why. Because yeah, okay, I know why. Let me undo. Is it 0? Yeah, good. Because you have to put like when you're running locally, you're running on localhost. But when you're learning in the playground, you have to do this. Or some equivalent to it. All right, here we go. Okay, so we have this little stupid hello print. I'm gonna get rid of that. We'll do that as an exercise. Okay, good. We have a 404. That's what we expect because we don't have any root for like index HTML. Where's the terminal? So now we're at 9003. And this thing is responding. And we also have a log. Excellent. And you guys even can access this playground until I close this window when I like fold down the laptop. Okay, good. So I think I'm like ready for the talk. I don't know if I'm gonna like show this right away because we're gonna like build this out, quote unquote. I'm gonna have this preloaded, the parser, and the show in this type. Maybe. I'm gonna probably just like hide the parser. I'm gonna copy paste it and just hide it in a buffer somewhere so we can actually like write the type out. And I'm gonna be like, by the way, I'm not gonna like spend 1 hour like writing this parser. And then we'll write everything else and just create this web app. All right. I think I'm gonna go prepare for that because I have to go in about half an hour to because I have to like commute for an hour to even get to the university. It's a little bit annoying, but that's how it is. All right, thank you to everyone. I'm gonna stream again tomorrow at the same time. I'm probably gonna work on either dream stuff or maybe some bisect stuff. And if you have any, again, if you have any requests you want to discuss or see anything, if you want to build a toy application of any kind, please let me know. You can do that either in stream or like on Discord or just anywhere else. And we can always just do anything because it's like it's not supposed to be only like dream development. Yeah, thank you, thank you. But it's supposed to also be just OCaml office hours and just whatever, like fun times. Yeah. I need to add a Discord bot, a bot that replies to the Discord. That's good. It's good that you did that. Yep. Hello. No, I didn't relocate. I can't relocate for like personal reasons. What do you mean relocate for support options? I'm still, by the way, yeah, I'm a U.S. citizen, so I'm like sort of between countries anyway. But yeah, it's fine. It's understandable. Okay. Yeah, I'm gonna put out that thing. I'm gonna figure out why Git bug isn't working. It's probably just running one of these terminals that I have. So yeah, thank you for attending the stream. It was fun. It was fun to like, yeah, of course. No, as I said, I'm also like a U.S. citizen, and basically the way I'm working now is I'm just working as an American. Although I'm trying to get the Russians to like support PL research. So we'll see if that happens. Like it's gonna be good for like Russia to be doing like some PL instead of whatever it's doing. But anyway, yeah, thank you. Enjoy. And I'll see you tomorrow, hopefully. Yeah, I understand. I understand. I understand that. So yeah, anyway, until tomorrow, we can just do whatever. Let me know. Otherwise, we're just doing like Dream and or Bisect and whatever's on my plate. Enjoy. I'm putting up that little like banner.